All right, number 3, let's take a look. This is from that geometry quiz, which is actually a homework. So it says line L contains these 2 points, 6, 6, and 0, negative 2. So if you plot those 2 points, you get a straight line, right? That's line L. Line L. And then it says point H, put an H right here, has coordinates of negative 1, 5. So that's point H. We want to find the distance from, from line L to point H. Okay? So that's what we got to do. I'm just going to sketch this real quick on here. I'm not even going to use the graph paper thing. We can do it without it. Yes. I believe so. Yeah, I've got a little bit of time. Why don't you just hang around and watch what we're doing here. Watch this. 6, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's make this in another color. What's red? It's good. About right there. That's 6, 6. And then 0, negative 2 would be about right there. Alright, connect them, make a line out of it. Just so we can kind of see what's going on. Oh, oopsie daisy, let me grab it. Right. Where is it? Where is that thing? There it is. Oh, no wonder I was... Well, yeah, the point. How'd that point get there? What's going on? Come on. Alright. Just put that point right there. Now we'll take the line and put it about right there. That's good enough. Alright. And what are we trying to do? We're trying to find the distance from this line to this point, negative 1, 5. So let's plot that. Do that in a different color. So negative 1, 5. 1, 2, 3, 4, 5. Okay? So what is the distance from this yellow point to this red line? It's perpendicular, isn't it? To there. Alright, so it hits the red line right there. And what was this point? This was negative 1, 5. Alright, so I'm going to go through kind of quick. So that's what we have right here. We want to find the length of that yellow line right there. So the first thing we're going to do is find the equation of both of the lines. Write that down if you need to. The very first thing, after drawing it out, the very first thing you need to do is find the equation of both lines. So let's take the red one and figure out what the equation of that line is. Now watch, this makes it actually a little bit easy because you've got this point right here, which is the y-intercept, isn't it? So really all you got to do on this red one is find what? Find the slope. Okay, and what were the points? It was 0, negative 2, and what was it, 6, 6? Okay, so we can find the slope very quickly. You know, don't waste a lot of time writing out the whole entire equation or the formula and stuff. Do it as quickly as you possibly can without making mistakes. Okay, so it's the change in y, right? Change in y over the change in x. So we subtract the y's. Negative 2 minus 6. What is, you can do that in your head. What's negative 2 minus 6? It's negative 8. And then subtract the x's, put it on the bottom. 0 minus 6. What's 0 minus 6? It's negative 6. Okay, let's reduce it. What does that reduce to? Positive, how about 4/3? Alright, positive 4 over 3. So that's the slope of this red line. What are we trying to do? Find the equation of that line. So now we know the slope, so it's y equals 4/3 x. Now on this one, this was kind of nice because they told us the y-intercept, didn't they? What if they did not? What if the point was not actually the y-intercept? How would you find the y-intercept, Brooke?
Would you use negative 1, 5 for the x and y, and then go?
No, not for the red one. No, the negative 1, 5's got nothing to do. Yeah, I want to find the red one. I'm pretending that they didn't tell us this point 0, negative 2. They didn't tell us the y-intercept. What if they didn't tell us? What if they told us some other point that lies on the red line? Okay, Emily?
You would do like the point slope form kind of, and be like y minus 6 equals.
Yeah, you could do that. You could do point slope form. That would be an okay way to do it. Or you could throw it back into the slope intercept form. Y equals mx plus b, right?
Oh,
and use one of these points and then solve for the y-intercept. Once you find the y-intercept, then you're good. But on this particular problem right here, they actually gave you the point that's actually the y-intercept. So they made this one just a little bit easier. Okay?
How do you know -2 is the intercept?
Because it's 0, -2. The point is 0, -2, which means it lies on the y-axis, and it goes through it, so it has to be the y-intercept. So it's y equals 4/3 x, that's the slope, what? -2. Remember what we do with once we get the equation of the line? I put it in a little box, okay? Just so I remember where it is. It's not the answer or anything, is it? So now I got to find the equation of this yellow line right here. Well, what's the first thing that I'm going to find? The slope, right? The slope of the yellow line. Why is the slope? Why is it easy to find the slope? Because it's the negative reciprocal of the red one. That's right. Okay, so if I know the slope of the red one, which I do, it's 4/3. What's the slope? Hardly without doing any math at all. What's the slope of the yellow one? It's -3/4. That's right. Makes sense? But now we have to find the y-intercept. They didn't tell me the y-intercept. I could sit here and guess what it is, but I don't want to do that, do I? I want to figure out exactly what it is. So let's do it quickly. Y equals mx plus b. Now what do I use? Do I know a point on this yellow line? Sure I do. -1, 5. So what's the y going to be? It's going to be 5 equals m, which is -3/4 times x, which is -1, right? Plus b. So let's see what we can do with this. That's +3/4. Agreed? Make sure I'm doing the math right. Alright, and then what do we do here? Subtract a 3/4, right? Now watch what I do. It's not really a sleight of hand, but it's a quick way to do common denominator. Let's rewrite 5, because I'm going to subtract a 3/4 from it, right? So let's rewrite 5 so that it's something over 4. What would you write it as? 20 over 4. Does that make sense? So 5 is the same thing as 20 over 4. Get rid of the 3/4, which is subtraction. And so what's the b equal to? 17 over 4. Okay? I would have never guessed that, would you? I would have never guessed that that y-intercept is keep it improper. Yep, don't change it to a mixed or anything, because the math just is a lot easier when you keep it improper. All right? So let's write our equation down. Let's put it right here. So it's going to be y equals what? -3/4 x plus 17/4. It's a little ugly, but that's what it is. Okay, that's where it crosses right here. 17/4, which would be what? 4 1/4, right? Okay, that's what it is. 1, 2, 3. It's not exactly accurate right here on this graph, but if you did it on graph paper, you'd see it's a little accurate. Dominique, can you make what? It's already printed out, ready to go. So whatever it is, it is. I don't know what numbers in there. No, don't turn that into a decimal. Okay, don't. I mean, you can, but don't. Okay? I mean, there's a big difference. Plus b, yeah. But they won't. They'll come out as fractions. They'll all work out as fractions. If they give it to you a fraction, write as or if they give it to you as a decimal, write it as a decimal. But these are going to come out to fractions. I mean, the slope came out to a fraction. That's why, right? Because you don't write a slope with a decimal. Never ever write a slope as a decimal. Write it as a fraction. Okay? Yeah, because rise over run, it makes sense as a fraction. Yeah, because I mean, like 4/3, that's 1 1/3. What if you said 1.3? Then you wanted to find the slope of the line that's perpendicular to it. Can you really take the reciprocal of 1.3 in your head? No, it's a lot easier taking 4/3, taking the reciprocal of 4/3. Wouldn't you agree with that? Yeah. Let's use fractions. Let's use fractions. Fractions are our friend, okay? All right, fractions are good.
Time to do it when I do
Absolutely,
decimals.
absolutely, okay? And I know your younger teachers, you know, the middle school and elementary teachers love to take fractions and turn them into decimals. And there are times that's good, okay? There's a lot of times where it's good to take a fraction and make it into a decimal. In this particular situation, I think it's way better just to keep them as fractions, okay? Now, we've got these two things right here. Let's pop back up here. What are we really trying to do? We're trying to find that point of intersection, aren't we? That's what we're trying to find. We're trying to find that x and y right there. How do we do that? Well, remember, this is the point of intersection between these two lines. It's the point that's in common. It's in common, isn't it? That point is on the yellow line and it's also on the red line. Would you agree? That's right. So this x This point right here, that x is the same x on the red line as it is on the yellow line. This y is the same y on the yellow line and the red line. Everybody see that? So that's the point of intersection. So that means the y is the same and the x is the same. So on both of these equations, the y is the same and the x is the same. We got to figure out what the y and the x are, though, don't we? So look, they're both equal to y. Remember what we said about y? They're both the same. All right, so we set them equal to each other. So let's set it like this. 4/3 x minus 2. All right, so see what I'm doing? I'm taking both of these equations and I'm setting them equal to each other. So I take that one, set it equal to this one. It's a little ugly because they're fractions, but, you know, let's just deal with the fractions, okay? So watch what we do. Let's add a 3/4 x to both sides. All right, that'll cancel. Let's add a 2 to both sides. Now watch this. I'm going to add it to a 17/4. I'm not just going to put plus 2. What's a better way to write it if I'm adding it to something over 4? How about 8/4? Right? Doesn't that make more sense? All right, so do the common denominator right there. That's what I would do. So let's do this. We need a common denominator with this, don't we? I got 3 and 4. That's easy. That's 12. 3 times 4 is 12, so 4 times 4 is 16. 4 times 3 is 12, so 3 times 3 is 9. So what does that come out to be? 25/12. I know I did it quickly. Go back, figure out how to do that. All I did was just add a couple fractions with different denominators. That's all I did. Okay, and that equals, what's this? 17/4 plus 18/4 is? Oh, I got an x here. I forgot about that. It's 25/4, isn't it? All right. Now, it still looks kind of ugly with these crazy fractions, but watch. They rigged this thing, didn't they? They rigged it so it came out really nice. Let's watch this. How do I get rid of 25/12 as it's being multiplied? Well, let's multiply. It is division, but it's multiplying by the reciprocal. So I multiply by the reciprocal here, multiply by the reciprocal here. Cancels. X equals, watch this. The 25 cancels. 12/4 is what? 3. Look at that. All those ugly fractions came out, and the x is a nice, pretty 3. Okay? Yes?
Wait, where did you get the 8 from?
Because 8/4 is 2. I just added a 2 to both sides. 8/4 is 2.
What if you don't add it like that, and you just keep it 2/1?
Well, then you still got to find a common denominator, and you're just doing it another step. You're going to find a common denominator no matter what, whether you do it here or you bring it down and you do it again.
It would be like the 4, right?
Yeah, right. But that's why I wrote it. But
you would multiply 2 by 2, right?
No, by 4, because it's 2/1, right? That's why you get 8/4. All right, let's keep going. So that's x. What do we have to do now? Find y. Where do I put the x? I could put it into either this red one or the yellow one. It doesn't make any difference. Either one, whatever the easiest one is. Maybe the red one, yeah. So y equals, you can do it either way. It doesn't matter. You still get the same exact answer. 4/3 times x. What was x? It was 3, and then minus 2. Look how easy this is. That cancels. 4 minus 2, so y is 2. So what's our point? What's our point right here? It's 3/2, isn't it? All right, so that point right there, let's slide it in here, is 3/2. That point is 3/2. Everybody good so far? It's a little bit of work, I agree. But you only have one of these, all right? So on the test, there's only one of these. So watch what we have. We've got -1/5. Let's do some different colors since we are doing something different now. All right, so we have -1/5, which is the point they gave you on that yellow line, and this other point that we went through all that work to find, which is 3/2. Now, what do we have to do? What was the whole idea behind this problem? Find the what? Find the distance, and this is actually the easiest part, isn't it? Finding the distance. So the distance is this nice formula right here. You guys should be pretty comfortable with this distance formula by now, shouldn't you? You hate the distance formula? I love the distance formula. I think it's nice. So watch. What do you do right here where the x's? You subtract them. Let's do it in our head. What's -1 minus 3? -4. What's 5 minus 2? It's 3. What's -4 squared? 16. It's positive 16, isn't it? Because when you square a negative, it's positive. 3 squared is 9. That's all under a square root, and that's the square root of what? 25, which is 5. Bang, there it is. There's your distance.
I did.
One of the points from the other line, is that okay? Or should we take
No. like for the distance, you have to take this point. You have to take this one because that's what you're finding. You're finding the distance from this point right here to this line. So you have to find this point and you have to use this point. Those are the only 2 points you can use. All right, that's the only distance right there. Yes.
You know how you square root of 25 versus 5? If it was like 12,
You can just keep it. If it came out to a square root that didn't come out even like this, like if it came out to the square root of 40 was one of the answers on the other worksheet, you can keep it like that. That's fine. All right, I'm perfectly fine if you keep it like that. In Algebra 2, you're going to learn how to simplify these things. You might have done that in Algebra 1, but as far as geometry, I'm fine if you just keep it like that. All right, something like this, if it comes out even, yeah, I would definitely make it a 5. Yes. Take a pass. Yes.
Will we have questions like number 24, like on 219?
I don't know. You have to show it to me. I don't have it
It
open.
says y minus 4th x. Like, there's only one.
Yeah, that's kind of like this next one on the quiz. Let's do that really quick, okay?
And we will have one of
Let's
those?
do number 4 on the quiz. Yeah, you'll have one of these as well. This one's actually a little less work. Okay. Yeah, that was definitely the hardest one. Out of the whole entire test, that's absolutely 100% the hardest problem. I would not do that one first. When you're taking the test, I would do the easiest ones, the ones that you can do the quickest. Okay, I would do those first. Okay, save that for the end because you always have test corrections, remember. Okay, you can always get it on test corrections. Right, exactly. Exactly. You don't want to spend all the time, get that one right, and then miss like 5 or 6 of them because you spent all the time on that one problem. All right, you gotta be smart about how you're taking the test. Okay, and with corrections, it's not going to kill you if you leave one blank, is it? Because you have the potential to get it right the next day and get 3 out of the possible 5 points. Exactly. Right. All right. So here's what we're doing: finding the distance. Find the distance again between these 2 lines. Now, they even tell you they're parallel, but they didn't even have to tell you that. We could have figured that out ourselves, couldn't we? Negative x minus 7. All right, here's 2 lines. How do I know they're parallel?
Because they have the same
They have the same slope. What is the slope to both of these lines? It's negative 1. Okay, so here we go. This is not near as much work as the other one was. Okay, so let's graph them both so we get a good idea what's going on. Negative 9. Again, I don't even care that it's perfect. Okay, there's negative 9 and there's negative 7. Is that all right? And then the slope is negative 1. So that means I rise over run. So I'd rise positive and run what? Negative. So about right there. Okay? Does that make sense? Let's do different color. What? Somebody said orange before. Okay, we'll do orange. I don't know if it shows up very well. Okay. Remember how to do this. There we go. Okay, there's that. And it's got the same slope, right? So I'm just going to copy and paste it and put it... You know what? They're kind of squished, aren't they? Would you mind if I just move negative 7 up there? Doesn't really matter. It doesn't have to be perfectly accurate. Yeah, I will. It doesn't have to be perfectly accurate, does it? Ooh, what's that? But there you go. So there's our basic thing. That's at negative 7. All right? So what are we trying to do? Right, a little far apart. It's not exactly to scale, but it doesn't have to be. Okay, this is just so that we get a sense of what's going on. That's all it's for. Okay, it doesn't have to be accurate. What are we trying to do? Trying to find the distance between the 2 lines. So where do I pick? I have 2 choices, basically. I mean, I actually have an unlimited number of choices, but to make this as easy as possible, I got 2 choices. Go from this point to here. But that line has to be what? It's got to be perpendicular. Let's go with this green. So I could go... What's that?
If you use like negative 9, you get the same answer.
You could use either one. I wouldn't say both of them, but you could, yeah, you'll get the same exact answer. Because look, if I did this, if I went from here to here, isn't that the same exact length? Yeah, because they're parallel to each other and the distance between them are going to be exactly the same. So I could do either this one or this one. It doesn't make any difference whatsoever. So I just pick one, okay? No big reason. I just pick that one, that's all. All right? So again, what do we have to do? Just like we did for the other one. We don't set them equal yet. What do we have to do, though? We got to find the what? Find the equations of both of those lines. All right. And what's nice about this one is, look, I'm finding the equation of this one. I'll tell you what. Let's go different color. Okay. We'll go blue and green. Is that all right? So we have to find the equation of the blue line and the equation of the green line. What's nice is I already know the equation of the blue line. What is it? Yeah, it's negative x minus 9. Okay. So that was cool, wasn't it? Look at this one right here. I basically know the equation of the green one as well. You have to think a little bit though. So what's the slope of the green one? It's perpendicular to the blue, right? So the slope of the blue one was negative 1. So what's the slope of the green one if it's perpendicular? It's positive 1, right? The negative reciprocal. So it's y equals 1x. What's the y-intercept of the green one? It's at negative 7. How do you know it's there? Because that's where I started it from. Okay, so it has to be there. Look how easy that was. That was nice, wasn't it? Finding the equation of those two. Now, what do I do with those two?
Wait, so are you using y is negative x minus 9?
Yes, I'm using the blue one and the green one. Okay? Because I'm using the blue one because I need to find that point right there. And that point right here, it's supposed to actually be on the line, but that point right there is on the blue line and it's on the green line. Okay? So those are the two that I'm using. Make sense? This is the green one, that's the blue one. So now, what do I do? Set these equal to each other. So let's do that. So negative x minus 9 equals positive x minus 7. Let's add an x to both sides, right? So we put it on the right side this time. Then I add a 7 to both sides. So what's x equal to? Oops, 2x. Sorry, 2x is equal to what? Negative 2. What's x equal to? Negative 1. So that's what x is. So that's this point right here. This point right here is negative 1 something. So now we just have to find the y. Remember, I could take either one of these equations. It doesn't matter which one I pick right here. Remember, normally I put them in a box. I forgot. There you go. So I could pick either this one or this one and put the x in. Let's do this one right here, okay? So y equals what? X, which is negative 1 minus 7. So what's y? It's negative 8. So what's my point? It's negative 1, negative 8. All right, so that's not so bad, is it? So negative 1, negative 8. Yeah, and then we just do that and we do the distance formula again. Okay, use that ugly color. And what's the other point? No, you can only there's only one. Because if I use this point right here, negative 1, negative 8, right, I use 0, negative 7. Because look, I'm trying to find the distance of the green line, right? So I've got this point, which I just found, negative 1, negative 8, and it has to use this point right here. I'm not going to use 0, negative 9, because I'm not trying to find this distance, am I? I'm trying to find the distance from this point that I don't know to this point right here that I actually do know. And that point right there is 0, negative 7. Everybody see that? So let's do the distance real quick. So distance equals square root. Boom, boom. All right, and let's plug the stuff in. So subtract the x's. Negative 1 minus 0. That's just negative 1. Subtract the y's. Negative 8 minus a negative. What's minus a negative? Positive. Negative 8 plus 7 is negative 1, okay? Negative 1 squared is 1 plus that one is 1. 1 plus 1 is 2. Square root of 2. Bang. There's my distance. And you're done. That was a lot easier, wasn't it, that one? Yeah. Okay. For which one? Look at the worksheets, that Form 2C worksheet thing. Let's do a couple of these. You're going to have several problems like this. It's not a distance, okay? It's just finding the equation of a line. So on number 16, they tell you the slope, and that's nice. That's half of what you need, right? And we actually kind of did this in the other problem, but this is its own problem, okay? This is number 16. All right, so look at this. They tell you the slope. They ask you to find the equation of the line. So this is what I do. Whenever they say find the equation of a line, especially when they say slope-intercept form, I write down the equation of a line so I know what I need to find. Look what they told me already. They told me the slope. So really all I got to find is what? The y-intercept. Now how do I find the y-intercept? They don't give you the y-intercept. Not on this problem they don't. What's that? I could go point slope. I kind of like this. You could go point slope, but I kind of like this way. All right, so y is what? 5 equals m, which is 3, times x, which is -1, plus 5. This works easy because there's no... And then that's -3 plus b. Add a 3. b is what? 8. It's not my answer, though, because it says write the equation of a line. There's too much going on. Hey. There's too much going on. Let's pay attention. So you got to write the equation of a line. So y equals what? 3x plus 8. So that's the equation of that line. Let's do number 17. Let's look at 17. They tell you the x-intercept. We've done these, but not that often. Is 3, and they tell you the y-intercept. And that's nice of them too, isn't it? Because they gave us half of it right there. They told us the b. If you think about this, what does it mean to be the x-intercept? It means it crosses the x-axis at that point, at 3. What is the actual ordered pair at that point?
0, 3.
How about 3, 0? Okay, so that point right there is 3, 0, isn't it? And look what I have. I already got a y-intercept. So watch. What was the other one? It was -1, right? So here's a point, and here's a point. What's the slope of this?
0, -1.
Rise 1, run 3. So what is it? It's 1/3. Okay? Or you could have made this 0, -1 and done the midpoint formula. So here's our formula. Watch. Or our equation. Y equals what? 1/3 x. What's the y-intercept? They told it to us. It's -1. Didn't have to figure that out. And there you go. So you're going to have quite a few problems like that. All a little slightly different variety. Like sometimes they won't tell you the slope. They'll tell you another point. Like, I don't know, 3, 4. They'll give you 2 points and you have to find the equation of a line. So what's the first thing you do? Find the slope, right. And then once you find the slope, you just do the rest, just like we did right there. Does that make sense? It's kind of like this. Find the 2 points, 3, 0, and -0, -1. What do you do here? Find the slope, find the y-intercept, but they actually told you the y-intercept on that one. They made it really easy for you. So you'll see a lot of problems like that on there, quite a few. I can't remember off the top of my head, maybe 5 or 6 of them, okay, that are like this. They're not all the same, but they should be easy. They should, if you know what all that stuff means. Yes? I think there's one where you have to do point-slope form, yes. Point-slope form is y minus y1 equals m times x minus x1. So if they give you a point, like that other one, this problem right here, they gave you a slope, and then they gave you a point. So watch, if they gave you this stuff right here, and they said put it in the point-slope form, it's really, really easy. There's really no math involved. It's y minus y1. It's the 5. This is your x. Yeah. That's your x. Yeah, you keep this as y. Right. That just stays y, and the y1 and the x1 are the things that you're putting it into. So it's just like this, and then it's 3, then it's x minus. It's minus -1, which is plus 1. That's point-slope form right there.
So what would that's it.
That's it. For if it says point-slope form. Right. If it says point-slope form, that's all you write. Yep. Pretty easy.